Hello, everyone, and welcome back to another episode of the React Native Radio Podcast. Episode 353, Node API, Support for React Native, with Kræn Hansen.
Welcome back, React Native Radio listeners. I'm Mazen, she's Robin, and we're React Native Radio. Today we have a fun topic for you, one that Robin and I kind of enjoyed prepping for, a topic that is deep in the weeds of React Native, so it'll be a fun one.
It was new to me. I had to do some research.
Yeah, same. And I'm glad it came with a talk and a blog post. So
yes, really appreciated that I could watch a talk to get some background.
Exactly. We have with us Kræn Hansen. Kræn, welcome to the show. It's nice to have you here.
Thank you so much. Thank you for having me.
Yeah. Why don't you go ahead and introduce yourself to our listeners? Let us know, how you got to where you're at. What do you do?
Mm-hmm. So my background is in databases. I helped build Realm, the mobile database, local first database and sync service. And I did that for about 7 years. And 5.5 years of that was at MongoDB since we got acquired. And Realm got deprecated and I got transferred to the developer tools team, and this is like less APIs and more GUIs and terminal UIs. But I've been spending a lot of my time with React Native and with this like databases, local first stuff. And now, since actually January 5th, I joined ElevenLabs, building SDKs for them on their developer experience team. So I can also talk a little about that, but I'm still learning right now. And speaking about learning, I learned React Native on the job at Realm. It's also it's many years ago now. And I've been slowly just building my knowledge around building native code for React Native, Node.js, the browser.
Nice. Yeah. Realm is one. Offline mode is one that I think we tend to always forget of as mobile developers, unless, it's a requirement on the app. You never know when, in today's world, does data actually drop off? Not necessarily, but always good to prepare yourself for that.
We're also chronically online. We forget that it's possible to be offline.
It's true.
Right.
It's true. We tend to forget, especially when we're just using simulators as we're building the apps. Mm-hmm. I think offline first is one part of now what has resurrected as the local first movement. I think something that's less obvious maybe is the developer experience when you use a local first approach. So when you have to cross a network barrier, you need to do some async work, like waiting for a network. And in that case, you need to have a waiting of promises, and you need to maybe do an optimistic update of your UI, and you need to handle rolling that back.
Yeah.
You need to show errors when stuff didn't work. And it's like disjoint from the point of interaction when you started the thing and then when you have to show the thing or retry the thing. But when you have all your data locally, you can afford to have synchronously blocking function calls when you do your changes to your database. And that's a massive increase in developer experience because you get the symptom of not being able to write to a database because you hit some invariant, like you created something with the same idea as something you already had in your database, but you get that like in the function, in the callback for your click handler, right? And that's a massive gain in developer experience. There's so much code that you don't have to write when you do it that way.
Yeah, that's awesome. Well, spoiler alert to our listeners, that is not our topic for today.
That's true.
But I think we need to have you back to talk about this.
Hey, it really sets the stage for how smart Kræn is and how much back-end experience and stuff he has, which is going to be really important for our actual topic, which is Node API, which we'll get to.
Before we do that, let's hear from our sponsor. Infinite Red is a premier React Native consultancy located fully remote in the US. We're a team of 30 senior plus level React Native developers and support staff and have been doing this for over a decade.
You fixed the copy. Good job.
If you're looking for React Native expertise for your next project, hit us up at infinite.red/radio. Don't forget to mention that you heard about us through the React Native Radio podcast. So let's get into our topic for today. Our topic is actually Node API support for React Native. Kræn, the objective of this episode, since it's very technical and kind of low level, deep in the weeds, is kind of make Node API, explain it like I'm 5 to us, and why is it relevant to as a React Native developer? We might be asking, I'll speak for myself, I may be asking some dumb questions. I like to say there are no dumb questions, but this is a topic that I feel like I don't really have the depth in because I don't necessarily know how Node will come into React Native. I've used it on the web, but not necessarily in that. So go ahead. Why did React Native need another native module path? Give us a kickstart on what is Node API in React Native.
Yeah, I think just let's start taking even a step further back. It's one of the big benefits of writing apps using React Native for many app developers is that they don't have to care about the native stuff. They can write JavaScript, and that's all they need to know in many cases. And I think that also goes for module systems like these native code module systems. Most application developers don't necessarily need to interact with Node API directly. And while in some sense you could just drop off and not listen to the episode. I hope you don't do that. But because there's some nuances to that statement, and also just having knowledge of what underlying technology a library is built upon also builds up more ideas and knowledge around how it can be used and the potential velocity you can expect from the library developer, stuff like that. What kind of interoperability you can expect. So as I'm speaking about this, I do want you to keep me honest when I'm trying, if I'm going too far in the weeds and I need to be drawn back to the topic. And yeah.
Well, let's as with most of our episodes, let's start high level, origin, motivation, and then kind of dig deeper into native stuff as we go on, right? So
let me talk about first up what is Node API not. Okay.
Perfect.
So we have stuff in Node.js that we know as the runtime APIs. These are the Node file system APIs or Node path or the process global, stuff like that. That's not what I'm talking about. Okay. So it's not how to access file systems or how to do path manipulation.
Which is probably mostly what our listeners have what they think of.
Yes.
Is you get FS from Node and
I'm talking about something very specific called Node API. I'm not talking about the Node.js API. If that makes sense, it's a very small distinction, but it's a huge difference. Okay.
Naming is hard.
Apparently.
Naming is hard.
So it used to be called Nappy. And because it's in some circles, it's considered a derogative term. So they renamed from Nappy to Node API. Yeah,
Makes
so it
sense.
had a name that was more different in the past. Yeah. Okay, so also just prefacing, if some of the stuff that I'm talking about here, maybe we can also leave this later in the conversation. But as you mentioned, I did do a talk on this at React Universe Conf, and we also have multiple blog articles on the Callstack blog.
Which we'll link all of it in the show notes. You should definitely watch the talk. Both Mazen and I watched it, and it's really helpful to see the code examples and stuff that are in there.
If we talk about the motivation, I think I started talking about Realm and why I got there, and I do think that it links back to my experience with Node API. So Realm had this C++ core library that we wanted to call into from Node.js, and we wanted to call into it from React Native, and it was really hard to maintain that implementation. To be honest, we had a C++ implementation against first JavaScript core, which was the runtime and engine that was used at that time in React Native. And then when Hermes came along, we did an implementation against this thing called JSI, the JavaScript interface, which is the preferred way of building C++ native modules nowadays, using turbo modules, calling into JSI. And we also at the same time had an implementation against Node API because we also published our library as a Node.js compatible binary. So we had to maintain at some point 3, and now because JavaScript core also there's an implementation of JSI for JavaScript core. We could get rid of one of them, so we had two. But it would have been so awesome if we could have just had like one implementation, and then we could have used that across all the different engines that we needed to support. And it's just really hard to maintain these implementations, especially when you have like a large API surface. Trying to write JavaScript in C++ is really hard. Like you have to do a lot of stuff that you don't need to do when you're just writing JavaScript, right? So I learned two things from that. Basically, I wanted to write native code using more modern and more opinionated tools for testing, docs, packages, stuff like that. And C++ might be a good tool for this in some trenches of the ecosystem, but it also carries like a huge legacy. I don't know how to put it, but that's just one thing. Like I think for me, the next native library that I build, I want to use Rust for that. In particular for me,
right?
Node API is not Rust only at all. Like it's a C++ based and C based API, but because it has like Node API is defined as a C API, so it has like a header file in C. Because of that, it's also callable from Rust in a nice way. So that's just one thing that leads me to my path onto like Node APIs. That I saw this thing where I could use Node API from Rust, and next time I wanted to build something native, I wanted to use Rust.
So that was kind of the initial entry point into this. You're like, I really want to be able to build native modules for React Native using Rust rather than using C++ or Kotlin or Swift. Is that in terms of JSI, which I think that's going to kind of be key for the listeners to really understand what the purpose of this is so, because I think most of them probably understand JSI at this point. We've talked about the new architecture a lot. Is Node API meant to replace like turbo modules in JSI for most libraries? Is it meant to complement? Is it meant to work with? Like, what's the relationship with JSI in terms, like conceptually? Is it a replacement or is it sort of a complement?
I would see Node API as a lower level abstraction that can replace JSI and turbo modules altogether. I don't think that you shouldn't see it as something that replaces JSI and turbo modules in your app like entirely. But I think from a library developer's point of view, you can use Node API instead of JSI and turbo modules. Right.
Okay. So yeah, it sort of serves the same purpose as JSI and turbo modules. And as a library author, I could say, I really want to write my library with something other than C++, Kotlin, and Swift, maybe Rust. So I'm going to choose Node API rather than choosing
with
JSI
I would say the caveat that like it is, I did this wrong because it is not a Rust only API, right? It's a
right. It's actually, it sounds like that's one of
it's just my motivation.
Right. That's your motivation, but it actually is quite multi-platform. It can be used for a lot of different platforms besides Rust, but yes.
Anything that has a C-based foreign function interface invocation like system can basically, that could be SIG, that could be Rust, that could be C++, Swift. All kinds of different, like Java, Kotlin, can all call into C APIs. And that's why you're able to use Node API from those. And some of those languages have better developer experience than others. And Rust in particular has a really good one, I think.
I'm going to let Mazen sneak in here.
Yeah, I had a follow-up question to what you said. So if I'm listening to this and I'm a library maintainer, this is mainly for me. If I'm an app developer, it pertains to me if I'm going down to the native side to build a native module, right? I just built a native module recently. Now, here's a question. Like, there are some native modules in today's world. Like, let's put Node API a little bit off to the side for a second. If I'm looking to build a native module, my decision comes on, can I build it in C++? Is it available in C++? Some aren't, right? For example, maps. So there's the Apple Map Kit or Google Places API, Map API. Those need to be built in Swift or Kotlin due to their nature. They might be UI based, view based. They might be module based. How can I, as someone who wants to use Node API and or one of these C languages, leverage something like this? Or is this a limitation, just like as is C++ today?
I think you're spot on. Like, I think it's a drawback that I haven't personally spent too much time building. If you remember, I used to build a database, right? And that's the angle of attack that I have in my mind. So I think there are opportunities, I believe, to orchestrate views over Node API, but it's not something I've done, and it's not something that I've seen done much of in the community, with the exception of NativeScript and Jamie Birch, where you basically they have a binding from from React Native into their NativeScript runtime over Node API. So they're very interested in doing that. But it's a little different. Like, it's basically where you expose all the platform APIs through a JavaScript interface, and they want to use code generation and Node API for that. But like, if you're just a regular library author doing views with Node API, is something that's just not done. It hasn't been done. So yeah, I think that's my most honest answer.
No, that totally makes sense. I mean, it's also a limitation of, like C++ right now, right? And that's something the community is working hard on trying to leverage and figure out, because it would be nice to, in the future, only learn one native language, so that a performant one, right? A performant native language, so that you can build views, modules easily, quickly, and also get the performance that we need in React Native, rather than having to learn JavaScript, TypeScript, Swift, and Kotlin. And now it's just JavaScript, TypeScript, C++, or, in this scenario, Node API specifically.
And I think two things that I wanted to say is that both Turbo modules and also Nitro modules are much more mature in a React Native context, but Node API is much more mature outside of React Native. So there's bindings and binding generators and tooling available for Node API outside of the context of React Native that we're also leaning into, where that's not the case for Turbo and Nitro modules. So there's like those two disjoint ecosystems potentially coming more together.
A lot of the excitement I've seen around this initiative to get Node API React Native compatible has been from people who came from other worlds and are now doing React Native and are wanting the functionality that they have used in other places to be available in React Native, and they're very excited about that.
Yeah, we've seen attention from the tangential communities, like the Links people from ByteDance and also the Vega OS by Amazon. Both of those are exploring using Node API as their module system. So there's also like a potential for interoperability between modules. And I think as a library author, that's something that I want. Like, I really don't want to have to test my thing across like all these different permutations of module systems, and I just want to write it once, and I want to get it out to as many people as possible. And I think Node API is potentially a future that can help me do that.
In the blog and in the talk, I keep hearing the phrase like ABI stable, and that's AB, not AP. Just to make things a little bit more confusing, we got AP. Node API is ABI stable. Briefly, what does ABI stable mean in practice for React Native developers and library authors? Why is that something that we would want?
So maybe you can see the difference as the API is the module, like the method names and the function signatures that you know from JavaScript. Like, you have this function, or like you have an object that has some fields, and then it has some methods, and then you can call those. Those are the signatures that it has, like the types or whatever. That's the API of the thing. And in C++, you have to be a little more diligent about, or like you have to be a little more detailed about it, because layout, as you're saving this object into memory, the order in which fields are presented in your struct or in your class actually matters on the level of memory. And when I have two parts of my process trying to access the same object with a given type signature, if one part of the system thinks that name came before age and the other one thinks that age came before name, like you have this problem where one is writing to the part of the memory in one layout and the other one is reading in a different layout. And this layout is what we call the application binary interface, because that's the binary representation in memory of the struct of the class.
So like what the machine is reading.
Yeah, how the machine translates raw memory into an understanding of the object, right?
So that's why traditionally all of our native modules that we're bringing in, we have to compile them locally after we install them every time.
Yeah, there has been some issues where if you have like a pre-built binary, like something that calls into other native code, and I built that on my machine, and I expect React Native to use a memory layout in a certain way, and that's like captured when I build my stuff. When then React Native goes along and updates by, for example, like putting in a new field in the top of that struct, everything goes wrong because I'm calling into it, assuming that it has a layout that it no longer has, and then the application crashes.
Right. Yay. Which is why updating is always traditionally painful.
So I think there's a tradition. It's actually like a big problem, I think, for the React Native ecosystem that we haven't really solved, but we are approaching a better solution. Meta has this idea that, and they also have discussions where they basically bluntly said we don't pre-build at Meta. Like we build everything from source at Meta, so we always get the latest source code and we just use that. And then you have folks at Microsoft that does the complete opposite thing, where they wanna do pre-built DLLs, like dynamic libraries that they can build once and then reuse forever, right? Without having to rebuild it again.
Interesting.
And that clash, basically, it's also what actually led Microsoft to build Node API support into the React Native windows. Was basically have like an interface between their native modules and their React Native applications that were API stable on the boundary between those.
Got it. Okay. Well, I kind of want to pivot a little bit to the developer workflow, developer experience type of perspective. Can you walk us through probably, as easily as possible, a minimal, hello world path a library author would have to go through to get, hello world to output on the screen, whether it's a module, that returns hello world and or just a view that displays hello world on the native side.
Mm-hmm. I'm frantically, right now I'm searching on the Callstack incubator GitHub. We have a good, there's like an example.
Oh, okay, yeah.
I'm going to pull that up. It's the Node API example lib. It's implemented in C++. It's a very simple add-on. It's just a add-on. When you load it, gives you an object that has a method called sum, and then you can call it with two numbers, and it will sum them up, basically. And what do you do as a library author? You have to declare a developer dev dependency on something called CMake RN. It's a tool that we help maintain to basically drive a CMake project, and the CMake is a meta build system. It's a system that you can use to generate projects, native code projects like Xcode projects or make files to build native code, C++ native code. And we use CMake RN, this tool that we built, to basically make CMake Node API aware. So it knows how to link against how to present Node API to your C++ code. There's another project called CMake JS, so not RN, but JS, and that was used in the community to do the same thing, exact same thing, but for Node.js specifically. So it's like it's a comparable tool, but for the React Native ecosystem. Okay, so you use that tool and you invoke it just with a CMake list txt file in your root, and that file basically just declares these are the C++ source files that I'm pointing to, and it has the version of Node API that you want to basically build with. Yeah, we can get into that later, but the Node API has a version basically that you can increase when you want to adopt new features. But that also puts a constraint on what environments you can run in, because some of those older environments that could be like an old version of Node.js wouldn't necessarily support that version of Node API.
Awesome. Yeah, we will make sure to include in the show notes a link to the GitHub repo that Kræn was talking about. It's the GitHub Callstack
and the Callstack incubator doc.
Yes, too. Exactly. We'll include all those. But I think Kræn mentioned that React Native Node API GitHub repo is very important and helpful to kind of get to visualize this. Because again, something like this, show me how I'm going to do hello world, is more visual than it is let's talk about it, right? But you did a good job of explaining it.
I want to talk a little bit about what like application developers can kind of expect the impact of seeing libraries built with Node API to be. It sounds like build times is probably one. If these libraries are coming for like pre-compiled, I mean, similar to what the React Native core team did recently with React Native itself, where it's coming in pre-built and builds are much faster. If our native modules are also pre-built, it seems like build time is going to be one like big impact that we may see for these specific libraries. Are there other advantages or impacts like we could see as application developers installing Node API build library?
And that's a great point. The build time, I didn't mention that. Like, because of the API stability that you hinted to, that means that you can pre-build these binaries, right? And for like a sum function, that doesn't matter too much. Like, it could be either or. It does matter in some ways. Like if I'm using some weird compiler setting or something like that, that might not be available on your C++ compiler, right? So there's something about being able to basically get your, as a library author, you get your errors as you're building your library. It used to be the case for Realm that we got this a lot. Like when Xcode got updated, people started posting issues on our issue tracker because stuff stopped building because some things changed in the way that the compiler read our project, basically. So instead of getting your issues, and basically when you're using a library that uses Node API, the promise is that the library author can get their compiler errors up front, and they don't have to rely on you posting issues when stuff breaks, specifically for compiler issues, which is it's super hard to reproduce those things. It's like, can you tell me what compiler version you used? And like, are you using some kind of compiler cache? Are you using any strange flags? Or, it's just a mess.
Yeah. Well, we're getting close to 30 minutes, so I kind of want to keep that in mind and shift a little bit to talk about like future of Node API in React Native and what has to happen and like what's next for Node API to basically be, let's say, pre-built by default in React Native so that it's available and it becomes real and everyone can use it.
I should have said this from the top. So the support for Node API in React Native has a prerequisite on Hermes, the engine supporting Node API. And there's a pull request that was opened by Vladimir from Microsoft in April, not last year, but the year before. And it has been building momentum, and like he's been building out tests. He's doing a great job. Okay, there's a lot of work that has gone into this, but we're still not at a point where it's completely ready to merge. There were some issues in Hermes having being built with Microsoft tooling for some time, and that has been unblocked. So now it's ready to be worked on again. So that's like one thing that needs to happen is for this the Hermes pull request adding Node API to merge. It's to be determined when that happens, but I also understand that it's a very hard ask to ask app developers to use a fork of Hermes. It is pretty opaque from the app developer's point of view. Like I've done a lot of stuff to like try to make it less daunting to build with a fork of Hermes. It's fully automated. You just have to run one command on Android, and then it's on iOS. It's driven by the Cocoa Pods project. But that's one thing. And then what other needs to happen? So there's some of the implementation of Node API that needs to happen in React Native in our what we call the host package, and that also has some outstanding tasks. And the main thing blocking that is basically having great tests to do this. Like we want to make sure that we implement it the same way that Node.js does it. And for that to happen reliably, I'm working on building something called the Node API compatibility test suite or compliance test suite, CTS it's called. And I'm building that in the Node.js repositories, actually. Like I'm trying to help them build this up where you can have this test suite that you can run across all the implementers of Node API, Bun, Dino, Node.js itself, and also React Native. So we can have like one big test corpus that we can run across all these implementations to just really make sure that we understand that we have a very good implementation, basically. Yeah.
Awesome. Yeah, thank you for that, Kræn. That was very helpful. And I think
this is super interesting and not something I expected to be super interesting.
Yeah. It's a very niche topic, right? And
it is, but it's really cool to see. It kind of feels like bringing React Native sort of like up to the level of a lot of other areas of programming.
I think when you look around, there's a lot of stuff happening in the JavaScript ecosystem around like Rustifying different implementations, like taking bundlers, taking formatters, stuff like that, and moving them into Rust. And something that really powers that is the binding generators of like Node API binding generators for specifically Rust. So it's like I just wanted to say, like, some of this seems very new and very risky, but we're standing on some very broad shoulders of a lot of people in the Node.js community that has done tons of work to make this reliable and stable.
Awesome. Well, Kræn, thank you so much for coming on the episode. This was very insightful and, kind of giving us another perspective on.
I feel like I understand
Yeah.
what Node API is and how it works and why you would use it.
Totally. And I urge our listeners, please, check out the show notes. We've put a lot of resources in there. And I'm sure, check out the repo, help out however you can if this is something of interest to you and something that can kind of help your project. Before we sign off, Robin, do you have a mom joke for us?
Oh, I have a good one. Why was E the only letter to get presents from Santa? Because all the other letters were naughty.
All right, listeners, I'll leave you with that for the end of the episode. See you all next time.
All right. Thanks, everyone.
Bye-bye.
As always, thanks to our editors, Todd Worth, Tyler Williams, and Jed Bartosky. Our marketing and episode release coordinator, Justin Husky, and our guest coordinator, Mazen Chami. Our producers and hosts are Jamin Holmgren, Robin Hines, and Mazen Chami. Thanks to our sponsor, Infinite Red. Check us out at infinite.red/radio. A special thanks to all of you listening today. Make sure to subscribe to React Native Radio on all the major podcasting platforms.